The energy transition is gaining momentum. The Dutch Climate Agreement aims for a 95% reduction in CO2 emissions by 2050. To achieve this, a lot of investments in wind and solar energy are taking place. But these weather-dependent energy sources come with increased fluctuations in the energy grid. To avoid overloading the grid, wind turbines have to be curtailed on some days. Additionally, wind farms are increasingly built far out to sea. Extensive subsea cables and transformer stations are required to connect them to the grid and are highly expensive. Hydrogen could provide a solution. Green hydrogen can be produced offshore with green electricity from wind farms. This way, electrons convert seawater into hydrogen, and this is transported to land via the existing gas infrastructure, which has more than enough capacity. When no new infrastructure is required, the future operation and maintenance costs can be shared between hydrogen and gas producers. Cost sharing can also stimulate domestic gas production. This way, North Sea gas fuels the energy transition even further. The PosHYdon project on the Q13a platform is the world's first offshore green hydrogen project. With the PosHYdon project, Nexstep, the Dutch Association for Decommissioning and Reuse, TNO, the Dutch Applied Research and Innovation Organization, and Neptune Energy, an independent international exploration and production company, are taking a first step towards a low-carbon future and a more integrated energy system on the North Sea. The Q13a platform, operated by Neptune Energy, is the first fully electrified oil and gas platform in the Dutch North Sea. It has been chosen by TNO and Nexstep for the 2-year PosHYdon pilot project to produce green hydrogen from seawater. The containerized green hydrogen production facility fits on most offshore platforms due to its small size. While currently powered by a subsea cable providing green electricity from shore, the platform can be directly powered by offshore wind in the future. During the PosHYdon project, the fluctuations in offshore wind production will be simulated. The production of green hydrogen begins with the platform pumping seawater into the containerized units. The water is then demineralized and fed into the electrolyser. The electrolyser splits the water into hydrogen and oxygen. The oxygen is safely disposed. The green hydrogen is blended into the gas export line. The PosHYdon pilot project on the Q13a platform aims to increase knowledge about the production of green hydrogen on offshore platforms and to innovate on existing technologies. By sharing our knowledge with Nexstep and TNO, Neptune Energy contributes to a broad adoption of hydrogen in the Netherlands. In the future, hydrogen-producing electrolysers can be installed on other platforms nearby offshore wind parks located far out on the North Sea. By combining hydrogen, natural gas, and wind power, we can fuel our society, our economy, and the energy transition.